Welcome back. Our next presenters are Pablo Artuso and Yvan Genuer. Their talk is titled Unauthenticated Access to SAP SolMan, Root Them All. Thank you so much for both of you, Pablo and Yvan, for supporting the Red Team Village and for supporting a Grey Hat. We look forward to your presentation and take it away.
Hello, everybody. Thank you for joining us in this presentation. In the talk of today, we're going to speak about the chain of vulnerabilities that we discovered a couple of months ago that will or may end up allowing unauthenticated attackers to get root access to every server part of your SAP infrastructure. So hope you enjoy our presentation. First of all, I would like to introduce us. We are Pablo Artuso and Yvan Genuer. We both work at Unauthenticated. Being part of the security research team means that we are mostly devoted to projects related with vulnerability research, and when the time comes, we are also the ones that perform penetration testing. This is our agenda for today. First, we're going to start with a brief introduction. Then we're going to have a brief chapter talking about the different findings and the details of each finding. The third chapter will be a chapter that we are going to share an experience that we face as a customer. And the fourth will be just some conclusions to end with the presentation. So let's start with the introduction. Why SAP? So SAP is one of the largest companies when it comes to developing software. In particular, SAP is devoted to business solutions, but these kind of business solutions are used by almost every mid to large company in the world. Also, these kind of solutions are protecting one of the most important data of the companies, like financial records or records related with employees of the company. So combining these two things is which makes, from my personal point of view, SAP really, really important and interesting target from both point of view. For the point of view that attackers want to access it, and also for the defenders to try to protect the data. This is an infrastructure that we're going to use as an example for the rest of the talk. We are going to keep coming back to this infrastructure when we are going to explain a new vulnerability. So it's important to have it clearly how this infrastructure is built. And so I'm going to explain it right now. We will have here, as you can see, 3 different servers. Each of these servers is running some particular OS and some particular SAP application. The reason why we have such a diverse setup is because we want to stress in this talk that the vulnerability that we're going to show you today will affect your SAP implementation and your SAP servers, no matter which OS are they running, no matter which SAP application are they running. And also, as any other SAP infrastructure in the world, there's going to be another component part of this infrastructure, which is the SAP Solution Manager. And I will let Yvan talk more in depth about these components.
Thank you, Partu. Hello, everyone. My name is Yvan, and I will continue to speak about SAP Solution Manager. What is a SAP Solution Manager? It's what we call a technical SAP system because there are no business data into it, but this is kind of system only used by SAP administrator to manage whole other SAP system. So we can represent it like that. SAP administrator connect only to this one to perform some administrator tasks to all other one. And it's very useful for SAP administrator because it's OS independent, database independent, and also a version independent. So you can use the SAP Solution Manager to perform administrator tasks everywhere. So you understand that SAP Solution Manager, it's highly connected with high privilege on whole other SAP system. So why we took a look on it? You can compare the SAP Solution Manager to a domain controller in Microsoft World. So if an attacker compromises the SAP Solution Manager or have a full access on SAP Solution Manager, this is completely a game over for the landscape. It can jump to all other systems and do what he wants. So basically, we think this is a technical hurdle of the SAP landscape. So this is why we decide to jump on it. The first thing we need to introduce is what is called SMD agent. So to be efficient, the SAP Solution Manager use a little component. This component is the SMD agent. It's installed in whole system you want to manage. So it's very useful because it's OS independent. It's work with Windows, Linux, and work with all database support by SAP, etc. So you can represent it like that in the picture. So the Subpost manager basically used the SMD agent to communicate with the system they want to manage. So the SMD agent can perform some diagnostic stuff, monitor the system, etc., etc. And behind the SMD agent, this component, these services run under one user, the DAA ADM user. So this is a little user without a lot of privileges, but so this is normal things. All right. One last thing, it's the SAP SolMan manager is what we call a dual stack in SAP world. So basically, you can connect using a SAP GUI, the normal SAP user interfaces, but also you can use directly a web browser, because there are web services hosted by the SAP SolMan manager. This is important because basically this is where we start. So yeah. So let's jump to what we find and how we find interesting stuff. So we separate in three steps. So the first one, it's how we find unauthenticated access to the SAP SolMan manager. And so let's jump on this first step. So the first question, the big question when we start for this kind of a huge system, it's where to start, because the SAP SolMan manager is a SAP NetWeaver with a lot of services, a lot of web services, etc., etc. So we decide to focus our research on the communication between the SMD agent and the SAP SolMan manager, and to look for web services involved in this communication. So we take a look on the SAP SolMan manager, and we find around 60 applications with SMD agent, etc., etc. in the name. And in all these 60, we figure out that there are 20 accessible through HTTP request, GET, POST, so something like that. So this is a sample of what we find. So basically, this is a web service size exposed by the SAP SolMan manager, and we start looking on all of them. And very quickly, we find several little vulnerability like this one. This is a blind external entity on these services. Also, part 2 found this one on the SVG convert. So he found a way to download image, but also to perform a denial of services by a CPU consummation. And also, I found this little one. Basically, we found a way without authentication to grep on files, so it could be efficient if you want to retrieve the configuration file, for example, etc., etc. The feeling behind this three little vulnerability, it's we find it very quickly. Like, I don't exactly remember, but it's few days. So it conveys us that we need to go deeper on this area, because we find all these several little vulnerability very quickly. So it's like a feeling. It's like a feeling. Okay, we need to go deeper. We expect something more. And eventually, I found this web service size, and this is the real story. I find the web service size, and I provide the URL to part 2 and say, hey, look what I found. It's appear very, very interesting with very powerful method, but unfortunately, everything is authenticating. And part 2 answered me back very quickly, no, it's not. And yeah, I double check, and he's right. There are no authentication. I fail when I test the authentication stuff, and so we get this web service size without authentication, and a very interesting one. So I'll let part 2 explain what we found exactly here.
So the EM application was a really interesting application. It basically allows SAP administrator to create scripts that will mimic user actions. These scripts will be uploaded to the EM application, but then are going to be deployed to an entity that are called EEM robots, which are the guys that are gonna finally execute those scripts. One thing there is that SMD agents, these agents that Yvan was talking about, could act as EM robots by default. So if you have, I don't know, 3 or 4 SMD agents connected to your solution manager, this means that you have 3 or 4 EM robots, at least. The final goal of this application is to have early detection of issues. So instead of having a actual user face an issue, if you could build a script that will mimic the action that a user is supposed to do, if that script fails, you will get a notification before an actual user faces. This is first a more graphical way. The first step is an SAP administrator creating a script and uploading it to the solution manager, and the second step when it gets deployed. But if you recall what Yvan was telling you, this EM application was exposed without authentication. So our first question was, okay, this means that maybe an attacker will be able to do the same thing as the SAP administrators. So in order to answer that question, we should and we needed to do a more in-depth analysis of the application. And with the goal of exploiting this and analyzing this application, we divided our whole idea in 3 different phases. The first step will be to try to understand how we can upload and how we can execute different scripts. Once we know that, we need to understand how we can build our own custom scripts. And once we understand that, we can start analyzing how we can make to abuse those scripts and probably perform some attacks like, I don't know, having a remote code execution. So let's begin with the first step, with the first phase, how we can upload and execute scripts. In order to answer that, we need to do a more in-depth analysis of the how this EM service works. It basically is a sub-service which exposes a lot of different methods, but we're going to talk about 4 of all those methods. The first important method was run script, which, as the name suggests, will allow you to execute a particular script. The second method is the get agent info that will retrieve a lot of different information from all the EM robots that are connected to your solution manager. The third step is a state HLS property. This method will allow you to modify a particular property from the EM robot that you choose. And the final method will be upload resource, which will allow you to, name suggests again, to upload a file or a script to your EM application. So, in order to execute and to start playing with this, what we did first was to choose a particular EM robot, part, of course, of this whole infrastructure. And the first method that we executed was run script. But unfortunately and surprisingly, the error message that we received was, hey, the EM is not activated. So we needed to find a way to turn it on. Our second step was to execute get all agent info, that we retrieve a lot of different information from all the robots that were part of your infrastructure. There, we detect that there was a property that was called EM enable that was set to false. So using the state HLS property, the other method, we modify that in our chosen EM robot, and we set it to true. Once after doing that, we execute again get all agent info, and this time we confirm that the change was made, and our 5th step was to run again the script, a random script. And this time we receive a very interesting message. It will say, hey, the full script, the name that you proposed, was not an actual and a valid script. This means that we were able to run scripts. But anyways, we needed to understand how we can upload a new script. So we start playing with the 4th method was upload resource. We first tried to upload resource, and this upload resource was receiving a parameter that was the content of this resource. We put some string there, some random string, and we receive a message that is really common. It's another really common mention or exposed by XML parsers. That was saying, hey, I was expecting an XML file and you didn't provide me that. So our last step was to try to provide an XML prologue, and the error message was, hey, yes, I recognize this as XML, but some content is missing. So at this point, we knew how to upload and how to execute different scripts. So let's go to the phase 2. That was basically how can we build our custom scripts. We start reading documentation. We start reading that there was an EM editor that was allowing you to create these different scripts. But unlikely at that time we couldn't use it. But then we realized that HTTP provides by default an example of an HTTP script. So by grabbing that example and start modifying and play a little bit with the error messages that were really verbose, we end up having and being able to create a script that was basically performing an SSRS attack. So we were able to create whatever HTTP script we wanted. And therefore, exploiting an SSRS, server-side request for share. So this was really good. It was a way to show the impact of having this application exposed without any kind of authentication. So step 2 was done. So now there was important time, a really good time to understand how we can abuse this feature that we had that we could build our own script. So let's start with phase 3. So as you remember, we have an SSRS that was interesting, but we were dealing with an application, again, an application web service that was allowing you to build scripts, and in particular, HTTP scripts. So having an SSRS is nothing surprising, right? So we wanted to go forward further and get something else from there. At this point, we shift from a black box testing to a white box testing, and we start analyzing the application because it was a Java application more in depth. We went to the grammar of the scripting language, and we understood that it was a message-based language, and basically the different types of the message was command. So from my personal point of view, every time that I see something that is called command, I go behind that because most of the time it's something interesting. Besides it, once we found this was a message type command, we went also to the parser and we understand what was this parser doing when it received something that was a message type command. And we saw that was executing some command, the command that was being provided by parameter inside the script. And all these commands were part of the whitelist. The only commands that were able to be executed were part of the whitelist that was defined in a kind of extension. At that point, we didn't know what was an extension, but we just throw a grep in the directory where the Java application was implemented, and we found a very interesting file that was showing all the different commands that were able to be executed, and also the classes, the Java classes that were implemented. So this was a really good resource to start understanding the different commands we have that were basically available to be executed. So now we have a list of 12 more or less commands that were able to be executed. And we start analyzing, okay, now that we have the different commands, what we can do with each of them. Can we maybe find a vulnerability inside of them? So we start trying with each of them, trying to understand what were they doing. And finally, we got one that was basically vulnerable to a remote code execution. We believe that something like the thing that is shown in the snippet was happening. That was basically this command was interpreting or evaluating JavaScript code and was actually executed. But the JavaScript code that you can execute it was provided by directly inside the script without any kind of sanitization. And it was important, and script engine, as you can see in the snippet, that is a really common bug in Java applications that were using this engine without any kind of sanitization. But if you recall of this, who were the ones able to access, to perform scripts and to create and to build scripts? If you remember that, as we said that this application was not asking for authentication, every person was able to create and build scripts. And the second interesting thing about this is that, if you remember, this application is part of the EM robots, and the SMD agents are by default EM robots. So this means that this application, or in fact the piece of the JS code that is being evaluated is actually being executed by the OS user that is running inside the SMB agent, which is the user DVADM, right? So this means that anybody or everyone could or can execute commands as the DADM user. So this was a really huge finding, and it was the composition of a phase 3 that may basically allow us to have a remote chain, a full chain of exploitation. So how the attack summary will work? First of all, the attacker will get all the agent info of all the EM robots, will choose the target, will modify if in case the EM is turned off, it will turn it on, and finally we'll upload the remote code execution script, and we'll after a couple of minutes will be executed those scripts. So here we have a quick demo. On the right side of the screen, you will see the attacker screen, which is pointing to the solution manager of the company. And as you can see there, we have 4 different agents. All these agents are we have 4 agents which are the same as you remember we explained in the example implementation. We have 4 different servers. This is the same thing. And as you can see on the left, every shell will start popping up from the different SAP agents that are connecting to a solution manager. As you can see, the first 3 are shells from a Linux system, but if you pay attention to the last one, that will be a Windows shell. So again, we are stressing here, there's no difference between OS. This attack will still work. So finally, as a conclusion here, to close this part, this means that an attacker without providing authentication will be able to execute remote code as VAADM, which is the OS user that is running inside the SMB agent. And I will let Yvan continue with the chain of vulnerabilities now.
All right, so let's jump to the third part of this research finding. Basically, how we would them all. To understand this part, we need to introduce a new agent. Again, the name is Subpost Agent. So the Subpost Agent, it's again a little component. It's present on every SAP installation, and it's here to help administrator to perform a lot of things, not only administration tasks like monitoring, start and stop the instances, etc., prepare for upgrade, prepare for installation, kernel upgrade, etc., etc. So this is very powerful agent, and again, this is OS and database independent. So interesting. Why we decide to look on this particular components? For 3 reasons. The first one is a couple of services run as root. So this is always a good thing to look on this kind of services. The second thing is we found that there are 1 port open on this component, the 1128. Okay, and the last one, and probably the most important one, it's we find that our user, the DADM, the user we are able to execute command from the SAP Solution Manager, is listed in the configuration file. And in this configuration file, it's listed into the parameter named service admin user. And it means what? We look at the documentation very quickly, and it means that this parameter lists the user, the local user, able to communicate with this SAP host Agent. So, okay, everything green light, a lot of green light, so let's jump. So the next step is to how from this SMD agent user DADM access we can perform or call for to do something with Subpost agent. All right. Normally, locally, the administrator use the binary in the SAP kernel provided by SAP, the Subhost control, to perform some to call for function provided by the Subhost agent. So this is it's happy to be very simple binary, and the list of the function is huge. When we call about function, we speak about hold this function. This is a lot of functions, a lot of already powerful function. This is all what we can do with the Subpost agent. All right. So we start to try to understand how it works. We try to perform some tests, and we figure out that when we call the Subpost control binary and we call for a function, behind the binary perform basically a lot of requests locally on the localhost on the 112A port, and all these requests is it's like web services and SOAP requests. So okay, we find a lot of web services exposed, etc., etc. So okay, the first issue we get, it's even if you are logged as DAADM on the system, if you call for a request to the Subpost agent to perform something, he asks for the DAADM password again. No, not again, but he asks for the DAADM password, even if you are logged as DAADM. So it could be okay in a normal case, but in our case, we execute command from the SAP SolMan manager, and of course, we haven't the DAADM password. So we begin to analyze the binary, and we figure out there are one feature called trusted internal connection. And what this kind of feature allow, it's to, even if you haven't the password, you can request a temporary password. Like, so you call for request logon file. This is a web service as exposed by the Subpost agent. The Subpost agent send back a path to a file, for example, logon32, and locally the user read the content of this file, and the content of this file, it's a temporary password. So the list of the number is a temporary password you can use one time to perform to request a function. So it's not very complicated, but everything is local. You can't perform it. You can't do it remotely. The request logon file is only accessible locally. But it means what? It means now without providing any password, you can call a Subpost agent function. So now from the SMD agent, you can communicate and do something on the Subpost agent. When we speak about call function, we speak about call all these functions. There are a lot of functions. They are already very dangerous functions. Like you can stop the instances, stop the database, change the IP address. Don't do that at home. We test it, and it's not good for the system. You can do a lot of things. So what we would like, we would like to find if there are a way to basically execute command as root, because behind all these functions, 99% of this function it's executed as root with very high privilege. Root for Unix and system for Windows. So let's speak about this function, for example, the execute operation. The execute operation, it's a function you can call to the SMD agent, to the Subpost agent, sorry, and you can call for different operations like the ping the Subpost agent, get some OS information, get the version or something like that. And we found out that one of these operations is vulnerable to a past traversal, and with this, by exploiting this vulnerability, you can force the SMD, the Subpost agent to execute Subpost exit. The hardcoded ./Subpost exit is executed, but you can execute it in your own directory, in the directory owned by DAADM. So it means what? It means you can force the Subpost agent to execute your Subpost exec malicious binary, and you can execute every command as root. So all right. We find it. Also, we found another one for execute installation procedure. This function is here normally to start the SAP installation. So for installing SAP, you use a binary named sapinst. And again, we find a way to trick the function and to change the sources of the sapinst, to change where is the Sapiens binary. So it means what? It means if you expose this kind of vulnerability, the Subpost agent as root execute all this command, and the last one, as you can see, it can execute Sapiens but from arbitrary directory. And of course, in this case, the Sapiens is not the real Sapiens; it's a reverse shell, and we get a shell as root like that. Another one, it's for this one. So this one again, it's we don't exactly understand what is the purpose of this one, but we figure out that you can prepare the system for an upgrade or for installation. It's just what you can do before launch for the installation. So with this one, you can mount, unmount, etc., etc. And when he tried to mount the file system, he mounts with root privileges, so it's very dependent of what you put in the file system. And what we understand that it's possible. So attacker prepare a malicious file system, for example, with only one file with a shell, and with the owner of this real shell is root, and the privilege is basically 4777, and transfer. Upload this file system to the target and use this function ICOS prepare to mount the file system, and the file system is mounted with root privileges. So again, we get a reverse shell like that. The last one we would like to share is, for example, this one. So deploy managed object from SAR. This is not the most simple function name. So this one is here normally to help to decompress a SAR file. A SAR file is basically an archive, a custom archive provided by SAP. So if you want to upgrade the kernel, for example, you download the SAR file from SAP website, and you can decompress using this function. This function check if the archive provided it's a SAP signed archive, so you can't create a malicious archive and ask to decompress it. We performed some tests, and we figured out it's not possible to overwrite file or to overwrite directory. So we find very little things. It's using this function, you can create directory everywhere, because, for example, if you want to write a directory in the home directory of the Subpost agent, for example, in /user SAP host control, normally DADM haven't the right to do that, but using this function, you can create a directory because you ask for uncompressed archive into this directory. And before uncompressed archive, the Subpost agent creates the directory, of course. So at the end, using this function, you can create every directory everywhere. And for example, you can create a directory in /user SAP host control. All right, like that, it looks like useless. You are right, but if you couple with another feature provided by the Subpost agent, it could be very useful. You will see. So there are one feature. It's named the Subpost agent have a self-upgrade process. It means what? It means the Subpost agent can upgrade this kernel automatically itself. And to do that, this is enabled by default, and what we understand about this process is every 5 minutes, the agent itself check if the directory /user /SAP /host control /new exists. If this directory exists, you perform an authenticity check into it. So basically, he calculates hashes, he counts the number of files, if the file have the good name, etc., etc. If one is missing, one verification fail, or whatever, it just stop. And if everything appears okay, he executes the Subpost agent execute as root the Subpost exec binary into this new directory. So the new Subpost exec and minus upgrade to upgrade itself. All right, so we analyzed deeply the binary involved in this automaticity check, and we figure out that if you create a file, a particular file named .force, it disables the authenticity check. So basically, it forces to install the kernel. So it means what? It means if we back to the process, it means that every 5 minutes the Subpost agent try to execute Subpost agent. That's it. And so if you remember, we can create you can create a directory in Subpost exec in a home directory on Subpost agent using the previous function, the function to decompress archive. So what kind of directory we can create? We can create a directory new. We decompress a valid archive, like whatever, and because this new directory is owned by DA-ADM, now we can create a malicious Subpost exec, Subpost exec, and execute arbitrary root command like that. Every 5 minutes, we need to wait 5 minutes. So you understand, we find several ways to execute command as root or system using this several little vulnerability in this Subpost. So one demo. So this is exactly the same display of the previous demo, but this time instead of just execute command as DADM, we try to exploit one vulnerability of the Subpost agent to get directly a root shell. So the vulnerability we exploit in this example, it's one related to the SAPinst, and as you can see. So on the right, this is the attacker point of view, and on the left, this is the pop-up, a shell pop-up, a root shell provided by the target system, and this is very quickly, very reliable, and very efficient. And so we have root access on whole SAP system, Linux, the SAP Solution Manager itself, and also the Windows one. So and everything worked very quickly and very well because the Subpost agent it's OS independent. So now I'll let Patu explain a real case scenario we figure out.
So the following chapter is an actual exploitation of this vulnerability in a customer. In order to give you more context, the customer's solution manager was vulnerable to the EEM vulnerability. This means that we, as vendors and testers, we have a blind remote execution that could leverage to gain further access. However, we have some limitations. The first limitation was that all the reverse connections were being blocked by a firewall, and the second limitation was that due to the nature of the exploitation of this bug, there were some characters that were not being able to be used in the command we want to execute. The only special characters that were being able to be used were the ones that are listed on the bottom of the slide. So we have a really interesting challenge here. We need to bypass these limitations in order to at least being able to read files that were part of the operating system of the files that were affected, of the server that was affected. I really like this kind of finishes because it's something that you have to do quickly and you don't expect, and well, you have to develop yourself quickly there. But the problem was that we have only 2 days. We were 2 days before ending the project, so I needed some help to develop and to think an idea really quickly. So I sent a message to a teammate and friend also that is part of the team, which is Pablo. And basically, all the following slides are the result of working together into this problem. So we need to find a way to read files, but we thought that maybe if we are able to write files, then we are going to be able to have a full remote code execution, which is something bigger, right, than only being able to read files. However, it was not possible to use write directions nor pipes. So it was at least something tricky to being able to write files, right? And after thinking for a while, we realized there was a command installed by default in every Unix system that may help, which was DB. So for those who are maybe not aware about this command, it's a really interesting command that allows you to copy bytes from a source point input to an output input, to an output basically, right? But the cool thing about it is that you can move within the file or the input file. And let's say, for example, that you want to copy only the third byte of a file and copy it to a, I don't know, second byte of another file, you can do that. So leveraging that feature, what we thought was maybe we can start copying from different and multiple input source files, different characters, and write all of them to a particular output file. And basically by doing this, we are going to be writing any file that we want with the content that we want. So we can write a bash script and later execute it. So this is an actual example of how to do that. On the left side, we have the command that we want to execute, ps redirection A. Remember, if we want to use the exploit for the EM, we are not going to be able to use this command, to run this command, because it has a redirection. And also, as you can see there, we are assuming that we have and we know the content of those files, the file1.xml and the file2.log. So for now, this is an assumption, and we are going to speak more about that in the following slide. So if we know this and we have this, what we can do is first we can execute a dd command that will grab only the character p from one of these two files, in particular from the file2.log. Again, we need to know the existence of this file and its contents. So afterwards, we can do the same with the S. We can do the same with the redirection, and we finally can do the same with the A. All these dd commands, we are gonna be writing the output to a file that in this case we chose to call rest.sh. So after executing all these dd steps, we're gonna see finally a file called rest.sh with the command that we want to execute. So up to here, we have a win. This means that we can write files, but we made a very important and huge assumption. That is that we know the content and the existence of those files. I would like to call those files like anchor files. And the big question we had is, okay, where can we get those anchor files? How we can be sure that they exist and that we know its content? First, we thought that maybe we can base on anchor files that are all the time present in the operating system related with the version and whatever. But that was a little bit difficult because, again, maybe a change in the version of the operating system will change everything, and it was a little bit difficult. Then we realized that Python was being able to execute. I mean, we could execute Python in a vulnerable server. So what we did was we set up an HTTP server by executing the module simple HTTP server from Python, and we realized that Python server, or that command, was being executed in a particular working directory that was full of TXT files. So if we create there, or if we execute an HTTP server there, those files are going to be served, and we have a lot of different anchor files that can be used. So leveraging these leveraging these two things, I mean, the way we can grab anchor files and the way we can write files, what we can do is have a complete bypass. The bypass will work. I will explain right now the bypass. On the left side of the slide, you will see the pentest box. On the right, the vulnerability remediation, and at the bottom, you will see the remote code execution that is being actually executed. So the first step will be, okay, we set up an HTTP server. As you can see on the bottom, every special character that is going through, I mean, the remote command it has all allowed characters, right? The second step will be to download all the anchor files that were served by the HTTP server, so there is not a command that is going to be executed remotely. The third step will be to do what we did with the DD steps, right? But we use a tool that we developed that is called DD encoder that will grab the command you want to execute, the different anchor files, and we basically output the list of DD steps you have to execute in order to have that command written into a file. The fourth step will be execute each of those DD steps in order to finally create that output file which is called rest.sh. And the final step will be, okay, now let's execute that script, and we are going to have a full remote code execution. Here we have a quick demo of how this works. First of all, we're going to use the script of the exploit for the EM, which we call unauth remote code execution, blah, blah. And here we are executing the command that we turn on the HTTP server in the Python. Then afterwards, we are going to show you that the PS redirectionary won't work, again, because that tariff is always blocked. On the bottom pane, what we're going to see is that we are going to issue a command that will grab all those anchor files. And while that is running, I'm going to show you that the DD encoder is a really easy Python script, and it's easy also to be used. We need to provide the anchor path, the folder where all the anchor files are present, which is the thing that we're going to download from the vulnerability investigation, the command, and the final or the output script that we're going to create in the vulnerability server. The output will be the DD steps. Then I'm going to see here, you're going to see just that some trick in order to bash scripting and start executing all those DD steps in the vulnerability investigation. So after a couple of seconds, you will see that the final script was created in the vulnerability server, and then it's a matter of executing that script in order to have the full remote code execution. As you can see here, we're going to execute those scripts, and after executing, what you should see is a new file created, which is we have named A with the output of the PS. So this was a really interesting trick that we had to use and create in a penetration test. I hope you enjoyed it. And now I will let Yvan continue with the presentation in order to close it.
So as a quick conclusion, we would like to share some things. The first one is we would like to sum up the attack. So remotely, without authentication, an attacker can access to the SAP Solution Manager, execute command on every SAP host to connect it to this SAP Solution Manager, and by exploiting some vulnerability on the Subpost Agent, it can leverage to root access or system access. So this is a very, very important attack, and the risk behind it's huge. So the post-exploitation, it's all over espionage, fraud, and sabotage. So you can leak everything, change what you want, and of course you can crash the system remotely and hold the system. So this is very important. We would like to provide the patches involved in this talk. So this is a list of SAP security notes. SAP security note in the patches, and also we provide another SAP security note. This is not the vulnerability we cover today, but this is also a part of our research, and there are some very, very important vulnerability correct in this SAP note against the SAP Solution Manager. So take a look on them too. So to answer the question if you are vulnerable or not, there are no miracle. You need to check the version. So if you are under this version for SAP Solution Manager or under this version for Subpost Agent, you are at risk. So there are not a lot of recommendations. The most important one is to keep up to date the SAP Solution Manager and the Subpost Agent. The SAP Solution Manager is very powerful system. We know that SAP administrator like the SAP Solution Manager, that they use it. So put it in the middle of your security scope, and very, very important system. You can find all references of the security patch, and also thank you to Onapsis Security Lab. Without you, nothing was possible. So thank you, and also thank you to SAP security team. We work a lot with them the last past years, and it was very, very efficient. So thank you everyone, and we wait for your question for sure. Thank you.